I like to keep things simple. When Kubernetes manifests are concerned, the best, and I repeat, the best option is often pure YAML. When that is the case, I think I did my job well. I created CRDs that are so simple that people confusing my services do not need anything but write a few lines of YAML. In some cases, that is not enough, and I might suggest usage of Customize or Helm. Nevertheless, there are cases when that is not enough either. Sometimes the definitions are so complex that I need more. And remember, I'm saying that I need more, not that I think that my users might need more. I will not lie. I am not fond of using programming languages like Go or TypeScript to define the state of something. I prefer declarative formats for the state, remember, not the logic, the state of something. Sometimes, however, that leads to the situation when I say to myself, gosh, I wish I could have libraries and conditionals and loops and other programming constructs. I still want the state to be declarative, but that does not mean that I do not want to simplify creation of that declarative state. Sometimes I want a programming language to help me create a declarative state which I can push to Git and let GitOps tools like Argo CD or Flux do their job. Oh, wait, someone is knocking on my door. Who is it? Oh my, cdk8s just came in. Let's see whether it can help. Let me introduce my guest. cdk8s is an open source software development framework for defining Kubernetes applications and reusable abstractions using familiar programming languages and rich object-oriented APIs. CDK apps synthesize into standard Kubernetes manifests which can be applied to any Kubernetes cluster. Now that was the official introduction of cdk8s itself. Those were its words, not mine. My thoughts are coming later. But right now, we are going to see what it can do. To start using cdk8s, apart from installing the CLI, we need to execute the command cdk8s init and then the name of the application. Now in my case, nothing happened because I already created the repo that I initialized using cdk8s. Everything is already ready and you can reproduce what I'm doing by following the instructions in the gist, and the gist is in the description, or the link to the gist is in the description. So go there and check it out if you want to reproduce what I'm doing. Wait, stop. Let me tell you about this video's sponsor, Zit. Zit simplifies quite a few things. It helps with deployment and management of our applications packaged as container images or serverless or Helm charts or application templates. It allows us to easily run databases like MySQL, Postgres, MongoDB, and Redis. And on top of that, it has native infrastructure as code framework support through Terraform, CloudFormation, or Pulumi. So if you need help with running your applications and managing your applications and underlying infrastructure, you should check out Zit. And not only because it's helpful, but also because by checking them out, you would be helping this channel. Now let's go back to the video. Now before we begin, let me state something that many of you probably already know. I like Go or GoLang. If you don't, then you can also use cdk8s with TypeScript or Python and Java. I think that those 4 languages are supported. So the examples in this video are in Go, but you can use any of the supported languages. With that being said, let's take a look at the main Go file that contains the initial set of instructions that I already created and that will be used to create the manifests I need. At the top we have some imports. I imported a couple of libraries. Then I'm defining a new application, and By the way, application is a group of all the manifests that we want to generate with cdk8s, not necessarily one application. So all the manifests we generate with the cdk8s backed application is an application. And in this case, I have two. I have something called silly demo, and I have something called AWS. Silly demo is a simple, silly example. AWS is a bit more complex. So we're going to start with simple, silly demo, and then show and iterate through a slightly more complicated example. So here I'm instantiating a new chart. Chart is a manifest essentially in cdk8s. So for every separate manifest file that we want to create, we create a new chart. And here I'm instantiating new application and passing a couple of parameters like, hey, this is the name of the application, those are the properties that I want to use, and that new app is a library that I made. And we're going to take a look at it right now. So let's cut or output app.go, and here I have a simulation, in a way, a mock-up of the library that contains typical Kubernetes constructs that should be used, or Kubernetes resources that should be used when constructing an application. There are a couple of imports, like always. There are some properties, and then we have instance of the new app, inside which we do some if statements to check whether the values are provided. If not, then there will be, actually the default values will be used instead. The real deal is happening in k8s new kube service, which is invocation of one of the libraries provided by cdk8s. In this case, this allows me to create a new Kubernetes service, and I can pass certain parameters. I can specify what I want, leave the defaults as they are, and this should give me a Kubernetes service. And then apart from the service, I need the deployment as well. So I'm instantiating new kube deployment. And again, that's cdk8's baked in library that allows me to create Kubernetes deployment objects that will be converted into YAML. And just like any other library, I'm using that invoking certain parameters and setting certain fields and so on and so forth. I'm doing the things that you typically do when writing applications in your favorite language. And this just happens to be Go, but it should work in Java, Python, and JavaScript, or TypeScript to be more precise. In other words, I'm using my programming coding knowledge for everything, and that everything includes how to create Kubernetes manifests, YAML version of Kubernetes manifests. And to create the manifests themselves, we can execute cdk8s synth or synthesized, and then it will synchronize the application and it will create the manifest. Remember, there is one manifest for each chart, and we can take a look at silly demo YAML file, and we can see here that the YAML was generated based on that Go code. We have a service and we have a deployment. And now comes the important question, very, very, very important question. Was this easier or better than writing directly YAML? Did I benefit anything by going through Go and using Go constructs? And my code is actually much bigger for this than if I wrote YAML directly. So is it easier to write and maintain it like this? And the answer is, for this specific example, it is not, unless what we need is more complex and more repeatable than my own example. In other words, if you need something relatively simple, you know, the typical things that you do in Helm charts or customize, and those typical things are specific to an application without much repeatability, without much complexity, then no, just drop this, go away, go somewhere else. cdk8s is not for you. Now, if you're still here, I'm going to show you a slightly more complicated example. I'm going to construct a more complex manifest based on custom resource definitions, or CRDs. And I will try to convert a slightly more complicated, yet not very complex, still not very complex, manifest of a cross-plane composition into cdk8s. Now, be warned, I'm not trying to promote crossplane today. That's not my goal. I'm only trying to illustrate something more complicated than a simple application manifest, and a crossplane composition happens to be what I had at hand. And if you're not familiar with crossplane, you might want to check those videos over there. But I will not talk about crossplane. I'm just using it as an example of me having something to do more complicated than what is a simple application. Now let's get back to the task at hand. cdk8s comes with core Kubernetes definitions like, hey, there is a library for deployment for service and so on and so forth. I, however, need more for my use case. I need to expand cdk8s libraries with custom resource definitions. So before we jump into a slightly more complex scenario, I will need to create additional libraries based on CRDs I already have in my cluster. So first I need custom resource definitions of crossplane itself, and I can add them. I can generate those libraries, cdk8s libraries, by executing cdk8s import, and then there are many different ways how we can import stuff, but today, right now, I'm going to use GitHub and I'm going to say, hey, I want to import libraries from the repo crossplane/crossplane, and I want to use the release 191, and my language of choice is Go. And you can see how cdk8s goes, evaluates all the definitions of custom resource definitions in that GitHub repository and generates libraries like API extensions, crossplane IO, composite resource definition and composition revision, and so on and so forth. So it generated libraries that I need to work to extend the capabilities of cdk8s using custom resource definitions stored or defined in a GitHub repository. But I need more. I also need CRDs from providers that I already installed in my cluster. And I can try something like, hey, how about I execute kubectl get CRDs and output them to JSON, and then pipe that to cdk8s import dev stdin, meaning use input as the input, and I want to transform those into Go. Now, this failed big time, and this is really disappointing because to begin with, this error does not tell me what's wrong, so there is no humanly possible way without diving into the code of cdk8s to understand why this doesn't work. It should work. According to the documentation, this is one of the ways to import custom resource definitions, but it doesn't work. Probably it has trouble with one of the CRDs or something like that. Anyways, this doesn't work, but that's not necessarily a bad thing. Even if that did work, I would end up having hundreds or even thousands of libraries, which is not ideal. That's much more than what I need. I eventually really need additional 10 libraries based on CRDs. So instead of trying to import all the custom resource definitions, I created a small script that will import and convert into libraries only those that I need. So let's take a look at the script. It's a simple one. So let's output getcrds.sh. So you can see what I'm doing, or to be more precise, I'm iterating through different CRDs that I need, and then for each of them, I'm executing kubectl get CRD, whatever the CRD is, output it to YAML, and then append to the file, to the YAML file, so that I end up with a file that contains all the definitions of all the CRDs that I want to import. So all I have to do is execute that script, execute getcrds.sh, wait for half a second, there we go. And now I should be able to import them by executing cdk8s import whatever is defined in that file, and the language is Go. Now, to be honest, I don't know why I'm typing the language, because after the initial setup, cdk8s knows that I'm using Go, but hey, it's a habit. What can you do? And there we go. We can see that additional resources were imported and converted into libraries. That's awesome. Now I should be able to construct my fancy manifest, the one that I'm really trying to create or maintain myself. So let me first display the end result that I want to accomplish, because I already have that manifest in YAML. That's how I was maintaining it until today. I was writing YAML all around. So let me show what I have right now, and then we're going to try to convert it into cdk8s and see whether I can benefit from that. So cut crossplane aws.yaml. This is a tiny fraction of the package, crossplane package that I have, and it's a simple one. I intentionally took simplest example because if simple works, then more complicated will be good as well. So this is the YAML, and there are a couple of problems with this YAML, problems that I hope that cdk8s will help me solve. To begin with, there is subnet A, subnet B, and subnet C resources, and that's a lot of repetition, right? I repeat the same 30-40 lines of YAML 3 times, even though there are only changes in the CDR block and the zone. Everything else is the same. I want to remove those repeated entries, not repeat myself. A bunch of other entries are not repeated in this specific manifest, but they're used across different packages that I have. So I might want to create a library from that so that whenever I need, let's say, Internet Gateway, I do not really write it from scratch again or copy and paste, but reuse that as a library. That would be the second goal I want to accomplish. And the third thing that I definitely need to accomplish is to move those last 2 entries somewhere else, because those 2 entries, actually, as a matter of fact, let me explain. This package creates databases in different providers, in AWS, Azure, inside Kubernetes, Google Cloud, and it could be Postgres, it could be MySQL. Now, what matters is that those 2 entries are used right now in AWS, but should be exactly the same in Azure and inside Kubernetes itself or anywhere else. Wherever I have Postgres, I need to have those 2 entries. So this is something that is not repeated within this specific manifest, but is repeated over and over again in different compositions within the same package. So I want to remove this repeatability, even though it is not so obvious right now that it's repeated. So what did I do? I created a couple of Go files. First one is aws.go, and this one defines everything required for me to define how to run Postgres or MySQL databases in AWS. I have get AWS resources, right? So I want to, because composition in Crossplane has the common parts that are the same more or less everywhere, and then resources that differ depending on the provider. And here I'm saying, hey, use this function to retrieve all the resources specific to AWS, and then there will be another function for Azure and so on and so forth. And this essentially is an array that says, hey, retrieve separate functions, VPC and subnets. Subnets are interesting, right? Because instead of repeating myself here, I'm just invoking the same function 3 times with different parameters, ABC, zones, and CDR blocks. And then the rest are invocation of other functions that give me subnet groups, Internet Gateway, and so on and so forth. And finally, outside of this source code, I have another one that is specific to commonly used Postgres functions. In this case, set up the provider and define the database, create the database. Now, the details are not important. What does matter here is that I'm using coding logic to define what I need, and based on the same principles as I would write code of any application. And then those commonly used SQL specific, Postgres specific in this case, functions are in a separate file, SQL Go, again, function and function and function. And finally, that is all tied together in the main Go file that says, hey, I want to create a new AWS construct, use the commonly used composition function, and then inject resources for AWS into that function, and so on and so forth. I'm doing the things that I would do if I would be writing code of an application. All the good things, or bad, depending on how good or bad of a coder I am. What matters is the end result. So let's take a look at what cdk8s created by outputting the contents of this directory AWS YAML, and we can see here the output YAML, the one that I would push to Git repo, right? And the one that would be synchronized with Argo CD or Flux. I got my YAML, except that I did not write the end result YAML myself, but cdk8s did it for me. I wrote Go code. So let me go back to the previous question. Was this easier than writing directly YAML? Well, Maybe. Depends. It really depends on the complexity that you're trying to tackle. What I showed is a fraction of what I need to define as cross-plane compositions. If I would have gone through the whole all the shenanigans that I did, everything that I constructed, then the answer would be yes, cdk8s was extremely helpful. What I showed here is a simple example, so you might not see how useful this is, but cdk8s helps a lot if what you're trying to do is really complex and huge, repeatable, and so on and so forth. I will talk about that more soon. Right now, we will talk about pros and cons and try to figure out whether you should be using cdk8s. So, what can I say? Actually, I can say quite a few things, and I will start with the most important statement, and that's that cdk8s is a great tool. I love it, and I'm currently in the process of moving thousands of lines of my YAML into cdk8s, or to be managed and created by cdk8s. Now, you might be asking, why? Why are you doing that? So, I will answer that in a second, but first let's go through pros and cons. And the cons, in the cons section, there is only one, and that's that simple is more complicated with cdk8s. That might sound strange, but if your scenario is simple, relatively simple, not overly complex and complicated, then cdk8s will convert something that is relatively simple and easy and straightforward into something that is more complicated to write, to manage, and so on and so forth. So do not, and I repeat, do not use cdk8s if what you're doing, what you're defining, does not warrant that level of complexity. And that's the only negative thing, really. So let me jump into positive things, into pros. And to begin with, the first one is the obvious one. I can use real code, the code that allows me while writing to have autocomplete and required fields and permitted values and to avoid repetition, and that allows me to test that code and so on and so forth. So a positive thing about cdk8s is that I can use real code, whatever real code means, because YAML is language of sorts, database language as well. So that's an advantage. Now, do not think that this is a huge advantage, because most of those things you have in anything else. If you configure, let's say, Visual Studio Code properly and you write directly YAML, you will also get autocomplete, and you will know what are the required fields, and you will know what are the permitted values, and you can test it more or less. Okay, that's a real advantage, and you will avoid repetition with cdk8s, but most of those things that we call real code applies to YAML as well, as long as you installed proper language server and configured it in Visual Studio Code. Nevertheless, being able to write Go or TypeScript instead of YAML sometimes is an advantage, and that's a positive thing. That's the first pro. Second, I do not need to check the API docs every single time I want to write something. Autocomplete does that for me. So I'm avoiding going through the documentation, which is great when writing something. What else? Yes, if your scenario is complex, cdk8s makes it simple. This is opposite from the negative thing I said. Easy things, simple things are less easy, more complicated with cdk8s, but complex things are simpler with cdk8s. And now comes my personal biggest advantage, because I'm a huge fan of GitHub Copilot, and Copilot works like a charm. I could just start typing something and then tab, and Copilot would end the line or the whole function. So most of those things that you saw today were actually written by Copilot, not me. And by the way, if you're not familiar with Copilot, check the video, it's over there. Next, yes, I love how easy it is to extend, to create your own cdk8s libraries based on your own CRDs. That was very important for me. Without that, it would be no-go. I would not even consider using it. What else? Oh yeah, the learning curve is less steep. It's smaller than, let's say, YTT or JSON, because I assume that you already know how to write code in at least one language, and assuming that that language is supported with cdk8s, meaning that you know how to write Java, Python, TypeScript or Go, then there is not much to learn, right? If you use JSONet or YTT, you need to figure out how those things work. And if you use cdk8s and you know how to write code in those supported languages, then there's not much to learn, which is absolutely awesome. And finally, the last thing, very important, even though other tools do that as well, is that cdk8s is focused on generating files, YAML files, and not interacting directly with the cluster. So my end result, the desired state, is still pure YAML. I can store it in Git, and I can use Argo CD or Flux to synchronize those manifests with the cluster, which is absolutely awesome. And that's about it as far as pros and cons are concerned. So finally, what do I think about it? Now, as I already said, I am in the process of moving everything that I have into cdk8s, or to be managed by cdk8s. Or no, that's not true. That's absolutely not true, what I just said. I'm not going to move everything into cdk8s. As a matter of fact, I will leave most of the manifests I have intact. I will, however, move all my crossplane compositions or crossplane packages into cdk8s. For my use case, and that's thousands and thousands of lines of YAML of crossplane compositions, cdk8s is a perfect fit. I discarded Customize and Helm almost immediately. They're not the types of tools for that type of the job. JSONet and the YTT seemed like a really good fit for what I need, but I have difficulties with those. The learning curve is steep. There are issues. I think that cdk8s is a better fit, again, for my use case. As a matter of fact, let me say it. cdk8s is just what I need. Now, I have no intention of moving end user manifests to cdk8s. That would be silly. After all, I'm not supposed to manage other people's manifests. I might be providing services to them, but I'm not supposed to manage their manifests. So, when should we use cdk8s? Now, move the complex stuff into clusters. Create CRDs and controllers and so on and so forth. So, do not use cdk8s or YTT or JSONet or Helm or whatever you're doing, so that on the client side or people's laptops, there are thousands of lines of something that is easier or harder to manage. No, move the complexity of what you have into clusters by creating CRDs, controllers, and so on and so forth. Use Crossplane, Kubella, or Metacontroller. There are many other similar tools to do just that. So from the end user perspective, complexity should be inside the clusters. And if you're not familiar with the tools I just mentioned, there are videos, check them out. Now, here's where cdk8s comes really handy, and that's to manage those same manifests of those CRDs and controllers and similar types of resources that are not end user manifests. For those, cdk8s is an excellent choice. Now, wait, stop. Before you leave, I have a very important question for you. I'm thinking of making a video that compares the tools used to manage Kubernetes manifests, like Helm, Customize, YTT, JSONet, cdk8s. I feel that it might be a good idea not only to compare those, but to give a recommendation which one should be used and when. And this is where you come in. Please let me know. Do you think that would be useful? Let me know in the comments.